In problem number 6, we're given that x squared minus xy plus y squared equals 7. We want to find the equation of the tangent line at the point -1, 2. So we already have our point here. Remember, the other thing we need to find for tangent lines is the slope. And so in order to find the slope, we'll need to find the derivative first. Make sure you find the derivative first, and then you'll use the point to plug in. So the derivative of x squared is 2x. Pay attention here, we have minus xy, that's another product rule problem. So I've got minus x, and then I've got my y. Okay, so the derivative of minus x is minus 1 times y. And then minus x times the derivative of y is dy dx. Plus the derivative of y squared is 2y dy dx equals the derivative of 7, which is 0. Double check, I have 2 y's, 2 dy dx's. Now, at this point, you could go ahead and solve for dy dx if you want, but there's actually an easier way to solve this problem. We have this point, and usually it's easier for us to evaluate with numbers as opposed to with letters and moving things around. So we have the point -1, 2, and so that is my x value and my y value. And so wherever there is an x, I will put in my x value, which is -1. Wherever there's a y, I will plug in my y value, which is 2. Notice dy dx I won't have. So I'm going to plug in 2 times -1 minus, this was 1y, so just minus 2, minus my x is -1 times dy dx plus 2 times my y value, which was 2 dy dx equals 0. And now we can simplify. Be careful here though. We've got -2 minus 2, that's -4. This becomes plus dy dx plus 4 dy dx equals 0. So kind of like before, we can move everything with a dy dx on the left side, which it is, everything else to the right side. So this would be 5 dy dx is 1 dy dx plus 4 more equals positive 4. So dy dx equals 4/5. That is my slope. But it asked me for the tangent line, and so I need to make sure I write out my tangent line. So I'm going to use that point and my slope. Y minus 2 equals 4/5 times x plus 1. And we can take a look at the graph here. We see the point -1, 2. It should make sense if we draw our tangent line. I'm just sketching it there, it's not perfect. It seems like it could have a slope of 4/5, like a little bit less than 1 when we look at it. In number 7, we want to find the points at which the graph x squared plus xy plus y squared equals 27 is either a horizontal or a vertical tangent line. So a horizontal tangent line means that my derivative or my slope is 0. A vertical tangent line means that my slope is undefined. So my derivative is undefined. So let's go ahead and find our derivative and then talk about how we can determine where it has a horizontal or vertical tangent line. And then we can match it up with the graph here as well. So we'll take the derivative first. So the derivative of x squared is 2x. For the derivative of xy, again, that's going to be a product rule problem. So we've got our x and our y. That's our two parts right there. So the derivative of x is 1 times y plus x times the derivative of y is dy dx plus the derivative of y squared, 2y dy dx equals the derivative of 27, which is 0. We see our dy dx's are on the same side. We had 2 of them. We had 2 y's to begin with, so that seems good. I'm going to go ahead and do that factoring all in one step here. So once you get more comfortable, you can do this all at once. I have x plus 2y times dy dx equals, on the right side, -2x minus y. So dy dx equals negative 2x minus y over x plus 2y. So we see that our derivative is a fraction, and so fractions are 0 when the numerator is 0 and the denominator isn't. They are undefined if the denominator is 0 and the numerator is not. And that's important because we don't want them to both be 0 over 0, because that would mean like I could have a hole or something like that. So we're really looking kind of like our vertical asymptote rules. We just want the denominator to be 0. So again, here for, if I'm looking at the numerator, that's a horizontal tangent where I'm going to look for it when the numerator is 0 and the denominator is not 0. And a vertical tangent when your numerator is not 0, but your denominator is 0. So think about if you divide by 0, that would be undefined. Okay, so let's find our horizontal tangents first. Let me go ahead and highlight that so you can see how it's matched up there. So all I'm going to do is take my numerator and set it equal to 0. Negative 2x minus y equals 0. And what I would get is just y equals negative 2x. Now that's not actually a point yet. And so what we have to do to figure out what the point is to plug it into my original equation. Okay, so I'm looking up at my original equation, x squared plus xy plus y squared equals 27. Wherever there is a y, I will replace it now with a negative 2x. So x squared plus x times, instead of y, I'm going to plug in negative 2x plus y squared, that's negative 2x squared, equals 27. And so we simplify now. X squared minus 2x squared plus 4x squared equals 27. So that's 3x squared equals 27. So x squared equals 9. So x is plus or minus 3. And so our points there, if we want to find the points, you could either use the graph to help you, or you can plug this back in. X is plus or minus 3, y is negative 2x. And so our answers would be positive 3, negative 6, and negative 3, positive 6 from that. Now, so far, these should be our horizontal tangent lines. However, you do have to be careful. We want to make sure they don't overlap with our vertical tangent lines. So at the end, we're going to check and make sure that those are not the same points. If they are, then our function might be undefined there, or our derivative just might be undefined but not vertical. So for the vertical tangent lines, I'm going to set the denominator equal to 0, x plus 2y equals 0. So I get 2y equals negative x. So y is negative x over 2, or negative 1/2 x. So again, I'm going to plug in for y in my original equation. So x squared plus x times negative 1/2 x plus negative 1/2 x squared equals 27. So I have x squared minus 1/2 x squared plus 1/4 x squared. And so that 1 minus 1/2 is 1/2, plus 1/4 would be 3/4. 3/4 x squared equals 27. And so then I multiply both sides by 4/3. I would get x squared equals 36. So my x is plus or minus 6. So notice that is not the same x coordinates over here, so I don't have to worry about them overlapping. So my points for my vertical tangent now are going to be positive 6 something, negative 6 something. You can plug it into the original equation, or you can just plug it into this y formula here because it should have that relation. So we have the point 6, negative 3, and negative 6, positive 3. We can double check on the graph here as well. If I look at the point 6, negative 3, I can see I have a vertical tangent here. Negative 6, positive 3, I also have a vertical tangent there. So just pay attention to those. And then for my horizontal tangents at 3, -6, oh, wrong one, 3, -6 over here, and up here for 3, +6 if I drew in my tangent lines there. So the graph there helps you with that. Sometimes you'll be asked to find higher order derivatives using implicit differentiation. So in that case, you have to make sure to solve for dy dx before you find the second derivative. When you find the second derivative, it will still have a dy dx in it. But then what you want to do is to make a substitution so that your final derivative is only in terms of x and y. So that's really important, only in terms of x and y. And usually it will tell you to have it only in terms of x and y. Okay, so in number 8, we're given x squared plus y squared equals 1, and we want to find the second derivative. So the derivative of x squared is 2x. The derivative of y squared is 2y times dy dx equals the derivative of 1, that's 0. So I can now solve for dy dx. 2y dy dx equals -2x. So dy dx is -2x over 2y. It's okay to leave your answer like this, but keep in mind we're going to find the second derivative, so if we can simplify this, it will make our lives easier. What we would get is -x over y. Now I'm going to find my second derivative. I'm going to switch up my colors here. So in order to find the second derivative, I'm taking the derivative of -x over y. I see that that is a quotient, so I will have to use the quotient rule. So I'm taking the derivative of both sides here. The derivative of dy dx is the second derivative. So d squared y over dx squared is how it is written, but we just say the second derivative of y with respect to x. Now I'm using quotient rule. Low is y, d high is -1, minus high, -x, d low is dy dx, all over y squared. And so what you want to be sure of here is that you actually go back. I see this dy dx here. I need to plug in what my dy dx was. I can't leave my answer like this. So I have -y plus x times -x over y, all over y squared. Now, again, it's okay to leave your answer like this. However, if you're on a multiple choice, it will not be like this. This part will be simplified. And so to simplify this complex fraction here, when I have a fraction within my bigger fraction, I can multiply by the denominator of that fraction times y, but I will also have to do that in the denominator of the big fraction. And so what I would get, make sure you distribute here, -y squared minus x squared. The y's would cancel out here on this term, but not here, all over y cubed. And so that would be my final answer for my second derivative.